Hello everyone, welcome to my channel. In this video, we'll be learning how to calculate the deflection at a certain point, rotation at a certain point, and the total internal energy of the system. Please don't forget to like, comment, and subscribe to stay updated for more civil engineering tutorials. Now let's start calculate this system step by step. Our problem is to determine the deflection at point B. This is a beam system. We're going to calculate the deflection at point B, the rotation at point B, and the total internal energy of the beam system. Now, in order to calculate this system, the first case is we make out the section of this beam system so as to obtain the internal energy. So is cut section at a known distance. When you cut section, it will be in this way. This is beam system of uniform distributed load. Here was 20 kilonewton per meter. Let's say cut section this at a known distance. It will be section 11, point B, point A. Point A. After cutting section, the system will be in this way. It will be in this way. This is shear force at distance x. We've cut a section at a known distance x. This is uniform distributed load, normal force at x, moment due to applied load, at x. This is point B. Now to obtain the deflection, so we take the summation of moments so as to obtain the moment due to applied load at point x. It takes the summation of moment at point x is equal to 0. Clockwise direction it will be positive and clockwise direction it will be negative. This is 20 kilonewton per meter. Okay, this it will be negative mx since it is in an anti-clockwise direction plus the moment at this point at the center of this system, which will be 20 x times x over 2 perpendicular distance, x over 2 perpendicular distance from this point to this point, x over 2, it will be equal to 0. Moment due to applied load at distance x, it will be 10x square. So after that, we remove in order to obtain the moment due to unit load, we remove all applied load and introduce unit load at point B so as to obtain the deflection at point B and the rotation at point B. So we say remove applied load and introduce unit load at B. It will be in this way. This is unit load at point B. Unit load at point B. This will be shear force at x, normal force at x, unit moment at point x. This is distance x, known distance x. In order to obtain the moment due to applied load for this system, so we take summation of moment at x is equal to 0. Local direction will be positive and local direction will be negative. So the moment at this point is an anticlockwise direction. So it will be negative mx plus 1 times is perpendicular distance. Perpendicular distance is x. So times x is equal to 0. Moment at x is equal to x. This is a moment due to unit load. So in order to obtain at Roman 1, we are required to calculate the deflection at point B. The deflection at point B. Deflection is obtained by taking integral from 0 to a certain distance, integral of moment due to applied load times moment due to unit load over EI dx. So deflection at B, it will be from 0 to 6 to 8. Our distance of this system is from this point, from point B to A, which is 8. So L of it will be 8. Moment due to applied load was 10x square. So it will be 10x square times moment due to unit load, which is x over EI. Therefore, when we integrate this one, deflection at point B, it will be 10x x power 4 over 4 EI from 0 to 8. So 10 of x power 4 calculate 28. We shall get here deflection at point B. It will be 10,240 over EI. This is deflection, so it will be meter. This is deflection at point B. Okay, Roman 2, we are required to calculate the rotation at point B. Rotation at point B. Rotation is obtained from integral of moment due to applied load times moment due to unit load dx over EI. Integral from 0 to a certain distance. Moment due to applied load we have obtained, but not to obtain the moment due to rotation. From this section, we remove the applied load and introduce unit moments at point B. So we say that in order to obtain moment due to unit load, we say remove applied load and introduce unit moment at point B. At point B means that moment at point B it will be equal to 1. So the system will look like this one. Moment due to unit load, this is shear force at distance x, normal force. From this one to this one is distance x. So here at point B, this is point B, we introduce unit moment, which is moment at this point is equal to 1. So in order to obtain the moment, we take the summation of a moment at x is equal to 0. Clockwise direction will be positive, and clockwise direction will be negative. So moment at this one, it goes in clockwise direction. So in anti-clockwise direction, so it will be negative mx plus moment at point B, which is 1, is equal to 0. So moment for this case, it will be 1. Therefore, rotation at B is equal to integral of moment due to applied load times moment due to unit load dx over EI from 0 to 8 is distance from 0 to 8. So rotation at B, it will be moment due to applied load we have calculated here, which was 10x squared times moment due to unit load, which is 1 over EI from 0 to 8 dx. When we integrate, it will be equal to 10x cubed over 3 EI from 0 to 8. Rotation at B, it will be 10 power 3 calculate unit. It will be 5120 over 3 EI rad. This is rotation. This is rotation at point B. The final case we are required to calculate is the total energy of the system. The total energy of the system. Total energy of the system. Total energy is obtained by taking integral of moment due to applied load times moment due to applied load over 2 EI dx from 0 to distance. Total energy, it will be from 0 to the distance, required distance is from point B, which is from 0 to 8 meters. So its distance is 8 meters. Integrate from 0 to 8. Moment due to applied load we have calculated, which was 10x squared times 10x squared over 2 EI dx. So total energy, it will be, it will be 100 x power 4 over 2 EI from 0 to 8 dx. When we simplify there, it will be 50x power 4 over EI dx. When you integrate for this case, it will be 50x power 5 over 5 EI from 0 to 8. From 0 to 8, total energy, it will be it will be 327,680 over EI. Therefore, the total energy of the system, it will be 327,680 over EI. This is joules. Now we have calculated the deflection at point B, the total rotation at point B, and the total internal energy of the system. Thank you for watching this video. Please don't forget to like, comment, and subscribe to stay updated for more civil engineering tutorials.